On number 28, it asks for you to establish the identity of sine 5 theta plus sine 9 theta divided by sine of 5 theta minus sine of 9 theta. And then that should equal negative tangent of 7 theta divided by tangent of 2 theta. Okay, so when you look at these and they ask to establish the identity, don't freak out. Just look at the identities that you've written down in your notes, because once you do that, you should realize that this is just two identities that we have. Okay, so this top is a sum to product identity. It's the sine alpha plus sine beta. And the bottom is another sum to product. It's sine alpha minus sine beta. So let me write these out for you so you can see them. Let me do the top first. Okay, so we have sine alpha plus sine of beta, and that equals 2 times sine of alpha plus beta divided by 2 times cos of alpha minus beta divided by 2. Okay, so now let's do sine alpha minus sine beta. So sine alpha minus sine of beta. Well, when you look in your notes, you'll see that sine alpha minus sine beta is actually 2 times cos of alpha plus beta divided by 2 times sine of alpha minus beta divided by 2. So knowing that knowing the top identity and the bottom identity, we can basically just then plug alpha into these equations and convert it into this form, and then from there we can go about converting it to look like that. So let's plug this in. This is our alpha, and this is our beta for the top, and for the bottom, this is our alpha, and this is our beta. Okay, so we get, I'll write it right here actually. Okay, we get 2 times sine of alpha plus beta, so 5 theta plus 9 theta divided by 2 times cosine of alpha minus beta, so 5 theta minus 9 theta divided by 2. That's the top. Now if we do the denominator, we should get 2 times cos of alpha plus beta, so that's 5 theta plus 9 theta divided by 2 times sine of alpha minus beta, so that's 5 theta minus 9 theta divided by 2. Okay, so now let's go ahead and simplify the insides. So 5 theta plus 9 theta, that ends up being 14 theta. Again here, this is 14 theta. Okay, but then it's 14 theta divided by 2. So we can cancel the 14 into 2. And we're left with 7. So this inside right here is 7 theta, as well as here. 7 theta. Now let's do these two where they're subtracting. Okay, so 5 minus 9 is negative 4 theta. But remember that negative 4 theta is divided by 2, so you can cancel. Negative 4 divided by 2 is negative 2 theta, and the same goes here. This is negative 2 theta. So let me rewrite it and make it look more readable. So we have 2 times sine of 7 theta times cos of negative 2 theta divided by 2 times cos of 7 theta times sine of negative 2 theta. Okay, sorry, there it is. Okay, so now let's stop and take a little breather, and let's look at these negatives. Now, if you remember your rules for sine and cosine, when you have a negative inside of a cosine, it just goes away. But when you have a negative inside of a sine, you can pull it out in front. So this becomes 2 times sine of 7 theta times cos of positive 2 theta divided by 2, let's make that negative come all the way to the front, so we get negative 2 times cos of 7 theta times sine of 2 theta. Okay, we're doing good. Now let's split all of that up pretty much like this. Like, let's break this into a fraction. Let's break this into a fraction because these both have the same inners, 7 theta, and these both have 2 thetas. So we'll end up with 3 fractions that are multiplying by each other. I'm going to get a new piece of paper. Okay. So we have negative 2 over 2 times sine of 7 theta over cos of 7 theta times cos of 2 theta over sine of 2 theta. Okay, so let's first look at our 2's. 2 divided by 2 is 1. Then it's negative, so that's negative 1. Now let's convert these into another trigonometric function. So when you have sine over cosine, that's actually equal to tangent. So sine of 7 theta divided by cosine of 7 theta is equal to tangent of 7 theta. Then this one, it's basically tangent flipped. Well, what's tangent flipped, you ask? Cotangent. And then we just keep the inners, 2 theta. Okay, well now you're probably like, Josh, that's not what we want. We want to get this. But we have this. Okay, let's do one more thing, and let's recall something. We just want to make a break in our notes. Let's recall that cotangent of theta is equivalent to 1 over tangent of theta. We're going to use this right here to get this bottom, the denominator of our fraction. So let's go ahead, convert this to tangent. So cotangent of 2 theta is equal to 1 over tangent of 2 theta. Okay, so now let's plug that in. So we get negative 1 times tangent of 7 theta times 1 over tangent of 2 theta. We're pretty much there. All we have to do is, since this is multiplying, just put this on top of here, like this, negative tangent of 7 theta divided by tangent of 2 theta. And there we go. We proved the identity. Because this right here is this. That's what we were looking for.